All right. Ready? So the plan was to take this course, this class, I mean this session, to go through some stuff that we'd have gone through before, mostly stuff to remember. So it would help as a, it would help as a guide of things to remember for, going forward with the labs, and also things to remember that may come on the mid-semester and the exam. So yes, we've been writing code, and I've been showing you the simple, or I guess the bare bones way of how to accomplish what it is I'm showing you how to do. But it is not to say that the way I showed you is the only way how to do it or is the best way how to do it. For example, I would have told you that when you're creating a new entity, the status code for that is supposed to be 201, right? But in practice, when I'm showing you the code, I don't always remember to put the 201. I'll probably just leave the default status code. I leave it to you guys to remember that the theory says when you're creating something, it's 201 and the rest of the other status codes. So things like that I want to go through, and I want to go through the different things that we need to remember for each of the different concepts and technologies that we've worked with so far. So like building APIs, the Arduino stuff, and also GitHub related stuff, because those things are important as well. So like I said a while ago, we don't use 200 for everything. Oh, by the way, I'm not going to be going through all of this. What I'm also going to do after this is some stuff that Dr. Faulkner asked me to include in the course this semester or this year is stuff related to building front ends as well. The website, the web page part of it. Because it's important for you guys to know how to do that for your final project. A lot of people that have web-based projects have a website or a mobile app that they need to build. And also, deployment. So after you're done finish working on your application and you want to make it available to the public, you need to know where you can deploy it to, whether you're going to be using a server, a Linux server, or a serverless solution, and the other options that are available to you. So we'll go through this briefly and we can move over into that other stuff. For the most part, it's really just text. So even if I don't cover everything, you can just open the slides. I'm going to post the slides and you can just go through it. Yeah. So, we need to know when to use the different status codes. We don't use 200 for everything. And it's not just that we need to know all of the status codes. We just need to know a good few of them. We know that 200 just mean okay, 201 mean created, 204 mean no content. And the 204 is specific. I see you guys asking questions in the group chat, what 204 no content might mean. It doesn't mean that you must say that it was deleted. You're literally supposed to not return any content at all. Yeah. 400 is bad request, 404 not found. And this 422 is one that is included usually by default. It's not one that I particularly like so much. I prefer, like usually, I think 422 might mean something like the request that you try to make is logically formatted properly, but the rules of the system, like the business logic of the system, just don't allow this kind of thing. Well, okay, so no. If you try to make a request that goes against what the pedantic base model defines, then that is a malformed request. That is a bad request. That's a 400. Yeah. Let's say, for example, it's like one of the examples that we'll be looking at is projects, where it's supposed to have a status and an engineer and a title and a description. And the description is one character. I think in a case like that, if I'm not mistaken, that would return a 422 because it has all of the things required to create a project. It has a title, an engineer, a description, and a status. But the business logic, meaning one of the small things that you as the developer want to protect against, is making sure that the titles don't have one character. It's still a string, but because it's a business logic related thing. And when I say business logic, what I mean is it is logically and syntactically correct, but the reasoning behind what the server is supposed to do has not been met. Yeah? So you get a 422 for that. So it is unprocessable because it breaks some business level rules. Yeah? And I was saying that 500 internal server error is another type of error that your server could return, but it means that if your server does return it, something is wrong that you need to fix. When I say you get a 404 or a 400, it doesn't necessarily mean that there's something wrong with the server, even though it is an error. It doesn't mean that there's something wrong. It doesn't always mean that there's something wrong with the server. You could get a 404 because you made a typo, like the URL is supposed to say /projects, and you put /project. And if you go into Postman and put /projects, you're going 404 because you don't know which part you're talking about. So it could mean that you get a 404 because of something that you need to fix. But specifically the 500 always means that you have something in your code that is leading to a bug and the application crash and you need to fix it. So you should not intentionally return a 500. If you ever say 500, it means that you need to fix it. Okay, so, right. The Pydantic thing as you were talking about a while ago, we, for the most part, want to use Pydantic to validate the data that's coming into our system. That's going to come in the form of your request bodies, whether it is a put request, a patch request, or a post request. Get requests and delete requests don't need bodies. So you wouldn't necessarily need to specify a Pydantic model for those. But we use those are the gatekeepers, right? So if your request has a body that goes against the design of the Pydantic model, then you need to make sure that it catches it. If it doesn't catch it, you need to fix it. This is something that we haven't gone through yet, the response model. So response model in Fast API, just like how you can specify the default status code of a function in Fast API, you can specify the response model. So basically, you're making it so that you don't accidentally return a JSON object that you're not supposed to return. Like, for example, if you want to have a post request handler return the created object entity, but you accidentally return a JSON that says entity created. Having the response model specified in the function will throw an error and say that the returned object does not follow the constraints of the response model. So basically, you're just making it so that the base model that you specified in Pydantic is being returned to the user as expected. Yeah? Let me see. Path parameters and query parameters, we haven't gone into that so much. We did go into path parameters. So a path parameter would look like this, where you have /project/ID. This is the path parameter. But we haven't gone really so much into URL parameters, where you want to, say again? Right, so if you want to query something, you want to return all of the objects that meet a particular criteria. So like you want it to return all projects that have a status of active. You put a question mark, and then you put whatever value you want to, or whatever key you want to query, and then the value that you want to return it for.
You can search some on Amazon, right? And you're looking in the URL bar, that's, let's say you're looking for a product. You look in the URL bar, that's like the search thing, and between it you have plus.
Well, the pluses, I'm not sure exactly what those are for, but I guess those are specific to how APIs, how Amazon's API is set up. But for the most part, if you're going to see the question marks and the equal signs, it's essentially this. It's the same thing. So it's Amazon's way of passing over the search details over to the API so that it can bring back the necessary results. Yeah. RESTful naming conventions is pretty important. So like you should use nouns, not verbs. You should use plurals. I guess typically use plurals, yes. So like in the examples that I've been giving you, if you have an API that's supposed to return projects, you use /projects. You don't say get project. You would say projects, and the word get would come in the form of the HTTP method that you're trying to make. So the URL is not supposed to tell it it's a get request. So you're not supposed to have get projects and then post projects and whatever else. Your all should just be projects, and then whether it's a get or a post or a put or a delete should come in the form of the HTTP method that you're sending. Yeah. Right. Oh yeah, and you can test. I'm not sure if it's something that you guys are in the habit of, but you use Postman to test your work. So, and I also provide the rubric. So I tell you, if a particular function is supposed to return the status code necessary to indicate that an entity was created, if you know it's 201, then you're supposed to use Postman to do a test and see if it actually come back with a 201. Yeah? Also, Postman has a built-in test framework where you can get all of your requests or all of your functions that you're trying to test, and you can click one button and it runs all of the requests for you. Yeah, so you can run more than one request. You don't in Postman, yeah? And it can generate a report of what passed and what failed. Yeah, you can do that in Postman. Some I can probably show you if we have time. But yeah, so like, I may or may not do that this semester, but it's something that I would have used last semester. So like if an exam is marked out of, not an exam, if an assignment is marked out of 20, I would have like 20 test cases. And depending on how many fail and how many pass, that's the grade you can get. Yeah. So I'll check to make sure that you have a request body, check to make sure that it returns a 200, check to make sure that the response body is a JSON and not an array, things like that. So yeah, you can look into tests or test collections in Postman. All right. Some stuff for the ESP32. This is something I found out recently. So for the ESP32, especially the ones that I have available, I don't know if it's for all of them. When you're doing stuff with ADC, yeah, not all pins will work when you're using Wi-Fi. So the safe pins to use are these ones here, 32, 33, 34, 35, 36, and 39. And those are on the left-hand side of the ESP. The ones on the right-hand side. Wait, sir. Wi-Fi is running. ADC 2 pins, including those, are disabled by the Wi-Fi driver. Yeah. So if you try to use these pins while using ADC, they'll give you garbage information. Yeah. Yeah, because I think the ESP turns those pins off or it uses those pins for other things while Wi-Fi is enabled. Yeah. So knowing your pin functions, not every GPIO supports analog read, but I think that's something that you guys are supposed to know from embedded. So get used to your pinouts. So look up your ESP32 pinouts, and I feel like not every ESP32 is the same. The bigger one, is that the one with the 2 USB ports? Why do you use that one? Oh yeah? Oh. Right. Okay. I've always seen that one with the 2 USB ports, and I wonder why it's so serious.
It's not really that much big difference from that one. I think it have like the pseudo RAM and more flash storage. I think it goes like 32 megabytes.
Okay.
It have a DMA, some sort of.
What are the 2 USB ports for? Why have 2 USB ports?
You can use it as a USB host or.
Oh,
yeah.
that's sick. Okay. Interesting. That's interesting. No, ECG, yeah. All right, this one, the first one, I think, did I mention this? I think I mentioned this yesterday. It's very important for you to check. Huh? You weren't here yesterday? Oh, right, yeah. But yeah, the video will be there. You don't watch the videos? Like you said that 99.9% chance you're not going to watch the video?
Yeah, but
they don't help? All right, well, yeah. So yeah, one of the things I'd gone over in yesterday's class is when I did the GET request last week, I would have shown you how to set up and connect to the Wi-Fi. And that's in the setup. In the loop now, when you're actually going to make the request, just because in the setup you connected to the Wi-Fi and you got an IP address, don't mean that when you're doing the loop, you will still have Wi-Fi. So if you don't have Wi-Fi, it don't make sense try to make the request because it definitely going to fail, right? So one thing to note is that in the loop, you can check to see first if you have Wi-Fi, and if you don't have Wi-Fi, just return and go back to the top of the loop and try again. If you do have Wi-Fi, continue as normal. Right? So that's one thing that is important for you guys to make note of when you're writing your Arduino code. Always remember to end. So where you have a http.begin, where you establish a connection to the server, you do an end when you finish with it. Live data to plot charts. Okay, let me see. So you said that everything that you look up tells you to use WebSockets. Does it say why?
Ask GPT and it's the WebSocket allow for back and forth communication, HTTP uploading.
Right. But why do you need back and forth?
Kind of fast. I mean, I know that GPT.
Okay, all right.
And YouTube use WebSocket.
Okay. So WebSocket is something I plan to cover. Let me see. When will I do WebSockets? I could do it Wednesday, next week, Wednesday. Because we have the mid-semester.
Next week?
When next week? And tomorrow? Not tomorrow. Not tomorrow. I can't tomorrow. Can't tomorrow. Next week Friday.
Next week Friday.
Yeah, next week Friday for sure.
That's what it's online.
It'll be on VLE. Yeah, so it'll be next week. So I think I can probably do a WebSockets example on Wednesday. But yes, so it depends on what you're trying to do. You said that you have temperature, right? And you want to be able to measure the temperature on the ESP and then send it to your server, and then the website will pull it from the server and display it on a graph. How frequent do you want the data to come in? You want it to be immediate? Okay. So if it is every second, that's different from immediate, you know. Because every second means you're going to make a request, then wait a second, and then make a request, and then wait a second. But immediate means as soon as it gets it, send it off. Yeah? So if it's once every second, you can use HTTP. Because it's just a case where you're going to be measuring, and then you send it, and then you measure, and then you send it.
So what benefits of WebSocket?
WebSocket is when you need right now. So WebSockets would be like, for example, if you and me having like WhatsApp. You don't want the server to be checking to see if I sent a message. And if I sent a message, then it must send it to you. You want it so that as soon as I send a message to you, it reach you, right? So that's when you need WebSockets.
So more things on the website though, because I'm creating profiles and I want to be able to stop and pass open and basically mimic the open user interface.
Right, okay, I see what you're saying. And I guess because it's an oven, if you want to mitigate the chance of something burning up, you want it to be as fast as possible. And since you mentioned back and forth communication, you'd want to make sure that as soon as you say stop the oven on the website, the oven stop in real life. So yeah, back and forth communication in that case would be useful. So I think it would be helpful for you to use WebSockets. So that's probably something I can show next week. So yeah, we can probably look into that next week. Yeah. The thing with the HTTP end I was talking about, so you end when you finish making a request, whether it's successful or no. Goldie, don't stop my class. Yeah. So yeah, you get the 200, you get the JSON body, and you parse it, then you end. But if it's a case where you don't get a 200 request or 200 response, you still end because you've begun before, and now you need to clear up your resources and make sure that there's nothing hogging any used up resources, so you end. Oh, and another thing yesterday I specified. So, remember when I showed you HTTP requests? Let me show you that again. Show that again. HTTP request example. Oh, here's one. No, this one. You remember earlier on when I showed you this? An example of a post request. So we'll have the different information that lets the server know what it's supposed to do when you get a request. This is the post, this is the route, this is the server where it lives, and these are some headers. These are information about the body. This being the body, but this is not in JSON. This is in URL encoded or form data or whatever you want in.
We're not going to use that.
No, we're not going to use this. No, we're not going to use it, but it may be important to know it. Yeah? Right, so when the server gets this request, it will know how to read this data because the request tells the content type is all of this, right? We don't use this when we're sending information from the microcontroller to the server. We use JSON. So we need to make sure that in addition to the actual JSON that we're sending, we tell the server that we're specifying that the content type is application JSON. So there's a function that you can use. I think it's http dot, where is it? Is it on this here? Add header. So you add a header to it. And adding a header doesn't only work with content type. Depending on whatever other types of content types you may need to include, would require you to specify, some different value. And yes, I did this yesterday. Because I did post requests yesterday. This will likely come in handy for next week's lab. Yeah. Because this week's lab is get requests. Next week's lab is post requests. Yeah. Yes. Yes. Yeah. And if you don't specify this when you're making a post request, the server will get the request and not know that there's a request in a request body in the request, so it won't know what to do. Yeah. So that's how you tell the server that what you're sending is a JSON. Sending the JSON alone isn't enough. You have to tell it that JSON is there. Mm-hmm.
The last lab the API is basically not the server, right?
The API lives on the server.
So that's basically the person, the software that validates data for the data.
What is the API? Hold on, let me see something. Let me.
Before we use the database, the server was basically the server and the database was basically running on our laptops, right? Before the database lab.
Hold on, one second. Server. Come here, ways to do. What was your question? What you said? You said before we got to database, what?
Yeah, I said the server and the database was on our laptop. We used what was that list to store the data.
Mm-hmm.
So that was running on our laptop.
Mm-hmm.
But now we have a database in the cloud,
Mm-hmm.
but the server's still on our laptop.
Mm-hmm. Right. So, all right. The API is the interface to your server. So think of it like, in order for you to make a post request, you have to go into Postman or whatever you're using to make your request, and you have to specify that the request type is post and the URL is /projects and all the information. Those rules, that's what defines your API. The server is what processes the information when the API get it.
Basically, API capture the information.
Yeah.
Server take that information.
And do something with it. Yeah. Yeah. Right. Mm-hmm. All right, no problem. Okay. Yeah. So now, Arduino JSON, a library that we used when we were using our ESPs, we use it to construct our JSONs. Whether we need to create a JSON body to send off in a request, or we need to parse a response body that we got from a GET request. Right? This says don't concatenate strings, meaning don't try to construct the JSON yourself using strings. Like, for example, you'd want to maybe do something like this, Sublime. So let's say, for instance, you're taking a temperature reading. You may be inclined to do something like this. You'd say string temp or JSON body is equal to, and it's say this temp this, no, not this, here, yeah. I don't know if it's right. Plus temperature or temp reading. And then this. So, would this work? Oh, plus this. right? I think this technically would work. So something like this is a way, if I wrote it properly, is a way that you could create your JSON body. So you create a JSON body by using strings to write out the shape of the JSON itself. I have this slash here to tell Arduino not to count this as the ending with double quotes. So this is the starting double quotes, and this is an escape. So it tells it to read the literal double quotes, not to treat it as the end double quote, which is over there. So yeah. So I have to escape this double quote and escape this double quote because the word temp is supposed to have double quotes around it. Yeah. So this is one way of doing it, and it would work. But what if you had a JSON body that had 20 things in it that you need to send? You'd have to do all of this. You could, yeah. That's more work. Arduino JSON does it all for you. Yeah. So it's a lot easier, and it's less prone to error in that case. Check your HTTP response codes. When I was doing GET requests last week, all I did was check to see if the response code was greater than 0. If it's greater than 0, that means it got a status response from the server. And then I just started parsing the JSON. But the thing is, if your status response is greater than 0, it don't mean it's 200. It could be a 404, it could be a 400, it could be a 500. Because that is a valid response from the server. So if it wasn't a 200 and you got back a 404 or a 400, and you try to parse the JSON that comes back from the server, you might not actually be parsing relevant data that the ESP needs. You might be parsing something else that comes from the server that you don't need to parse. So it's important that you check for the status code that you're expecting to come back. So if it's 200 you're supposed to get back, and 200 means you get back a JSON body, then you can parse it. But if it's not a 200, if it's a 204 or a 400 or something else, then you'd need to know how to handle that in your code appropriately. Make sense? Mm-hmm. And yeah, it talks about serial print. Very important. If you're doing something in your code and it's not performing the way you expect it to, just print out whatever you can and see. Instead of trusting it blindly, make sure you print it to the serial monitor so that you can see what it sees. Yeah? It's the only debugger you have.
That's for the ESP, right?
Mm-hmm.
So like Wi-Fi, all the Wi-Fi processes run on port 0.
I don't know. Yeah, I don't know. But what are you saying?
Reason why come have certain things that we call delay in my code.
Mm-hmm.
So if I like tie that to the Wi-Fi, then I have to affect it.
Oh, okay. Yeah, not sure. Ask chat. I don't know. Yeah, okay. So add delays in between your requests. This is actually something that I was not very accustomed to doing, because in my experience, when you make a request to a server, it takes some time to actually get back a response. It takes some time to establish the connection to the server, and it takes some time to make the request, and it takes some time to respond. So all those different time-taking processes would automatically, naturally give you a delay in your code. And I thought that was enough. In a case where it is not enough, might come in the form of, let's say for instance, you are making a request to a server that rate limits how often you're able to make requests. And when I say rate limit, what I mean is they may have rules put in place to say if you send 10 requests in a matter of 10 seconds or one request per second, it will halt you and it will block you to say, yo, you do too much. You send too much information one time, you need to take time and you need to slow down. So there are some servers that will do that. The servers that you build don't have that implemented by default. But if it's something that you wanted to protect against, for example, if you wanted to maybe prevent against a DDoS, you know about DDoS? Denial of service. Exactly right. Yeah, DDoS. Oh, I didn't plug my laptop in? My laptop is? Oh, all right. Yeah, so yeah, a DDoS attack or distributed denial of service attack. As you said a while ago, if you spam a server until all its resources get consumed and it's unable to address any of the other legitimate requests. Yeah. So that is one way of hardening your server, but there are kind of ways around it, but you know, we're not going to get into that. So you may want to, depending on what server you're making your request to, put some delay in between each request. And I've seen stuff online that says that you shouldn't be using the delay function because when you use the delay function, yeah, the CPU can't do anything else. So you may want to use millis. Depends on what it is you want to do.
Delay that you're talking about communicating with the server, that's why we use the async something.
The async stuff, yeah. So if you don't use async, the server will pause while it handles this request, and it won't be able to handle any other request. So we use async so that it can handle it. Not really. It's like, my understanding is that it allows you to allocate a particular task to like a thread on the CPU instead of the whole CPU work on this. So it's like it's working concurrently. Yeah, it's kind of like parallelization. Kinda, yeah, kinda. Right. Okay, so yeah, we use millis instead of delays. Now GitHub stuff, very important. GitHub stuff, just remember what to put on your repo and what not to put in your repo. We do not commit our venv. We don't commit the .env, the pycache, .pio, and the node modules. This is for JavaScript. I'm not sure if it's something you're going to come into contact with. Maybe it will. But yeah, just a list of stuff to remember. And the git ignore should be in the root of the project. Yeah. If there is one in there, make it stay. Don't trouble it. Make a new one, correct, yeah. And your git ignore, I think I've said this in the past as well, it does not fix your past mistakes. So if you accidentally commit something to GitHub, and then you put a git ignore to ignore it this time, it still exists in a past commit. So you could use this command, git rm cached and then the file, and that will help you to delete the file. Or you could just delete the whole repo and start afresh. If that's not something that you want to do, then use this. Git rm cached and then the file name. I can probably give a tutorial on how that actually works. I don't know, I've never done it before. I think I've done it before, but I never tried to commit it to memory. I just Google it every time. But yeah. Yeah. Yeah, so you don't leave certain things inside your code. You don't put your API keys, your passwords, database URLs, stuff like that. We don't leave that in our code. Let me see, deleting the file, a new commit, yeah. It's the same thing as before. You may have to delete it. Yeah. Oh, and I guess I would have also forgotten to specify that the way that we write our labs, when you're submitting them, they should follow this naming convention. Just for ease of use. Like some people will name them thing assignment 1 or lab 1 or whatever. I want to keep it uniform, so we'll be using this. If you don't say this instruction explicitly in the lab, just remember to do that. But it should be in the labs. And when you're writing your commits to GitHub, make them meaningful messages. So like when you're supposed to give a message to yourself, don't just say update or fix or stuff or just hit the keyboard. I do this all the time, but you should not. Yeah? Write out a message that tells your future self what it is you did in this commit. And if it's too much, split up the commits into different commits. Yeah? So if you have commits that are related, only commit these files and say that you added the post requests and you added, database integration, and then you add the other files and then you do another commit and then push it off all at once. Right, exactly. See, future you will appreciate it. Yeah. And also, yeah, this is also very important. If you want to make sure that your code will work for me, after you finish writing your code and you trust it, delete the code and then pull it back from GitHub and test it again. If it works fresh, then you're good. If it doesn't work fresh, then something is wrong. And you need to make sure that it works fresh. You can delete your code off your computer, yeah. So like it's just a way to make sure that it works. After you've committed it to GitHub, delete it from your computer and then download it back from GitHub and see if it still works. If it still works, then you're good. You use, so you go like pip install -r requirements.txt, like this. Yeah. What else? So yeah, when you're setting up, so this is a function that I will be using whenever I want to test your work. So when I get your work from GitHub, I need to make sure, or rather you need to make sure that there's a requirements.txt in your file so that I can run this command, and when I start it up, it runs. If I run this command and it don't work, that means you forgot to comment. Well, either it named different, or it could be a case where, do I have it here? I feel like I had it. It could be a case where, where's the one that said pip freeze? There's something in this about pip freeze. All right, I don't remember where I had it, but it's a thing where if you did a pip install at the beginning of creating the project, and somewhere down the line you never remember to include this particular library, and then you forgot to pip freeze, it means you're using a library in your code that you did not have in your requirements.txt. You get what I'm saying? So like, you get what I mean? So like, for example, you install Fast API, you install UVcorn, and then you're writing your code, and then later you get to the part where you're supposed to integrate your database. So you install Motor. Let's say, for instance, you remembered to do a pip freeze after you installed Fast API and UVcorn, but you didn't remember to pip freeze after you installed Motor. That means now your requirements.txt don't have Motor in it. But you did install Motor, but the requirements.txt never know. So when you send your code to me, all I'm going to see is Fast API and UVcorn. I'm not going to have Motor. So when I do my pip install requirements.txt, it's not going to install Motor. I won't be able to connect to your database because I don't have the libraries that you said I was supposed to use, right? So yeah, pip freeze is your friend.
But you would have seen, like, you would have seen the underline in the top of the code, show that they do have.
Yeah, but me not supposed to read your code. I just supposed to run it. Yeah. Me not supposed to read your code and say, oh yeah, I use Motor, let me install Motor theme. No. It's supposed like I don't need to read your code to know if it works. I just need to run it and run my tests. If my test run and it fail, that means there's something wrong with your code. Me don't know what's wrong. It just means it fail. But yeah. So yeah, this you can use this slide as a quick checklist. This is, did we even go through this? I don't even remember. This is something that we're going to have to talk about when we get to connecting your front end to your back end. Something I had to learn the hard way. And it's definitely going to come up for a lot of people. So it's something that we can probably go through. Actually, we may need it. Oh yeah, I think we're going to need this before next week, because this week is the get request lab, and you don't need it for get requests. But next week is a post request lab, so you're definitely going to need it. Okay. So yeah, you can use this as a quick checklist to go through your stuff. Make sure you have everything. And yeah, that's it for that part. All good? All right. So let's do some quick tests on how to make a request from the browser. Since I showed you how to do it from an ESP. Okay. Is this week 8? I think it is. I'm going to ask chat to spin this up real quick. So what can I do? I'm just spinning up a simple API. Oh, I should make it an array. In the meantime, this is something I do ago. I'm doing up a mock API, and I'll show you how to consume this API in the front end. Let me change this to app.py, and I'll do my Python -mvenv. You can look what Postman does. Okay, pip in wait. This venv scripts activate. Pip install fast API UV corner. That's it. All right, so I'm going to start this off. I'm going to say UV corn -m. No. Let's go again. App :app -- reload. Okay, so if this was your API, let's do a test and see what this looks like if you just make the request from your browser. So I'd say localhost 8000 / what is it? Sensors? Sensors. So you get something like this, right? But this is not a website, right? You would want to add stuff to your website. Ideally, maybe you'd want to put this stuff in like a table and make it so that the person can scroll through the table. Or if it's not a table, maybe you'd want to pull out a certain, like maybe the most recent value so that it says, you know, this is the most recent temperature value and it updates over time. So let me show you how to do something similar to that. I'm going to create a new file here, right, the HTML file. And ideally, at least in my opinion, depending on how the structure of your project is, you don't always put the front end and the back end in the same project. There are times when you want to keep them separate, depending on how complex either system is. There are times when you can put the two of them together. If it's supposed to be a simple application, you can keep them together. So I'll call this index.html. And just like how I tell you guys to call it app.py for default reasons, index.html is also for default reasons. When you're hosting your application, index.html is usually searched for first, and it uses that as the home page. When you're hosting, so you know, like when you're running your C code, you know that the C compiler will always look for the main function, and it will execute whatever is in that first. A lot of hosting providers will always look for an index.html and just display that as the home page. If you don't have an index.html, it's going to show you a list of files, and you're not going to know which one to open. Yeah? So yeah, we use the index.html. So I'm going to use my shortcuts here and create some scaffolding. And let me see. So this is my HTML. For your HTML, assuming you know HTML already, you're going to be adding stuff like your title, the subheading. Okay, let me do this again then. I open VS Code, created an HTML file, and I typed ! and it gave me some options. I'm just going to click on the first option. Yeah, it does it for you. You click this, and it gives you all of this. All you need to start doing is writing your code inside the body. So these are your body tags. Yeah, this is where your content goes. So if I want a title, I use a H1. H1 stands for heading. So this is my website. Let's see what this looks like. Let me just reveal in this. Open this. That's my website. Yeah. And then.
So browser process this data from HTML file and display that.
Yeah. So H1 means header, and you have H1 down to H6. The difference between them is just the size. H2, so it's a H2.
That's directly from VS Code.
Yeah, this is just a text file, yeah. So this is a subheading, and I refresh, this is my subheading. So it goes from H1 all the way down to H6. So H1 is the biggest, H6 is the smallest. And you can use them for your headings and your subheadings and your sub-subheadings, and so on and so forth. If you want a paragraph of text, you use a P tag. So this is a paragraph. Refresh that, that's a paragraph. Here's just some text. Yeah. Okay, and I was showing, let's say, okay. So this is just some static information. This is static data that does not change depending on the server. This is just always going to be here because I hard-coded it into my HTML file. But if I wanted to dynamically pull some data, then I would need to use JavaScript. So I can write some JavaScript in my HTML file, or I can create a file separately. I'll create a file separately. I'll go over here and I'll create a new file and I'll call it script.
The JavaScript, the language specifically for website.
I think it was originally specifically for websites, but it's not only for websites anymore. You can use it and write. I have taught this course in JavaScript instead of Python before. The very first time I taught this course, I taught in JavaScript. And that was a nightmare. But it was a nightmare because I taught it in both JavaScript and Python at the same time. So class used to be Monday, Tuesday, Thursday. On Monday I teach Python, Tuesday I teach JavaScript. And I did that every week, and it was difficult. So I stopped doing that.
So which one would it be easiest, Python or?
Two of them are same to me. Let me tell you, if you're very familiar with C, then JavaScript is going to be easier because C is very similar to JavaScript. Let me see, okay. Let's pull the data from the website and then display it on the web page. Sorry, pull it from the server. Okay. Try to remind myself how to do that. It's been a while since I've done this. So I'm going to say fetch. So there's a function called fetch, which is the function that you can use to pull data, or make a request rather, not pull data, make a request to an endpoint. Okay, no, I don't remember how to do this. Let me see. JS fetch example. I do not remember how to fetch. It's been such a long time. Okay, so you say fetch, then you specify the URL. All right, let me just copy this. Copy that. Okay. Okay, so I say fetch, then I need to specify the URL. The URL in my case is just my local host because the front end and the back end are on the same computer. Local host 8000, and the URL is sensors. Right? After you do that, you do a then. You take the response and you convert it to a JSON because by default, the response is just going to be a response with a bunch of other different things that you may not be able to use. May or may not be able to use. So you turn the response into a JSON, and then the values that you converted into a JSON will be stored in this object, and now you can just use it as you wish. This example here takes the data and just print it to the console, meaning it will print it, wait, wrong one. It will print it, how do you do it again, F12? It will print it here. So your browser has a serial monitor, for example. So you can print stuff here. So let me go back to my web page and open the quote-unquote serial monitor. And I'll run this, and let's see if it works. It doesn't work because I don't think I have anything that's actually, oh, I forgot to tell the HTML to actually run this code. So this code here, script.js, yeah, they're not linked. My mistake. I need to link them. So I'm going to go here, and I'm going to create a script tag, script source, and then specify that it is the script.js. So script tag, specify the source, and the source is the name of the file. So I think now I should be able to just do this. Okay, it broke. So it worked, but it broke. Why did it break? It broke because it got a 200, but cores. Okay. So this is not really something I thought I was going to have to teach so early, but I may have to. Okay. So, and it's in the slides that I showed a while ago. This word right here was the bane of my existence when I was doing my final year project, right? I have my front end that was making requests, and I have my back end that was able to fulfill those requests. But for some reason, because of this thing, CORS, cross-origin restriction, and the S stands for something, I don't know. Basically what we were saying is, because your website is on some system and your API is on a different system, they're not allowed to talk to each other because they're two different things and they don't know each other. Was it sharing?
Cross-origin resource sharing.
Cross-origin resource sharing, thank you. Yeah. So because I have my website running here and my API running here, security measures are in effect and it will not allow it to actually make the request. So you have to go into your code. The way to fix it is to go into your API code and tell it that it can allow requests being made from this particular host. That I also don't remember how to do, so I'm going to look it up real quick. I'm going to say CORS fast API. So go like this. And you should be able to just copy. So I need to add this library, add it up here, and then you specify the origins. And the origins is going to be a list of web pages that are allowed to make requests to your API. So in our case, I think I just need this last one here. And then I need to tell my application that it must take that list of origins and consider them when they make requests. So, oh, this is supposed to go down here. Actually, I can put the both of them down there. So put this here. So this is a list of origins. Yeah. Okay, so this list here, allow methods and allow headers. It's, okay, oh, so this one is allow origins. This origins is the same as this origins. So you're telling the middleware to allow all of the websites making requests from this URL. Allow methods, you can specify whether you want external clients to be able to do GET requests or POST requests or patch requests or whatever. Whatever you want them allowed to do, you put it here. If you want them to be able to do everything, you put an asterisk. That's why that's there. And headers, if it's a case where you want to allow or disallow particular headers, you have this here as well. This means allow all of them. Okay? Okay. So with this implemented, I should be able to restart my server. And if I refresh the web page, I really hope this works. It doesn't work. What did I do wrong? Did I spell this correctly? 8,000 sensors. It says it got at 200. It says from origin null has been blah blah blah. Localhost. Oh, you know what? This isn't actually localhost. Okay, I think I need to serve this. So VS Code also has an extension that you can use called Live Server that you can use to host your front end. So Live Server. So when you have this installed, you can, you know what I showed you wrong? I showed you the wrong thing. This is not supposed to be here. This is supposed to be the port of, or rather the URL of the front end that is making the request. So I'm going to put here 5500 and you'll see why in a second. I'm going to use Live Server to host this web page. And then it's going to allow me to make the request from port 5500. So I'm going to change this to localhost because it matters. Localhost. Okay, so that's localhost colon 5500. And now in my code, I specify here that I am allowing localhost colon 5500 to make requests to my API. So by default, Live Server hosts the web page on port 5500. So the API is running on port 8000 and the front end is running on 5500. So I tell my API to listen for a request that is coming from localhost colon 5500 and allow it. So now this should, oh, it did work. There it is. There's the array. But what is this? The server responded with the status of, oh, this is the favicon. This is something else. You can ignore that. But yeah, so the code ran and the JavaScript ran, and it made a GET request to my server, and it returned these 3 things from the server. But it's just testing. I just wanted to print it in the console and see if it actually printed. Let's put them on the web page now, if I can remember how to do that. Okay. I'm going to create a div, and a div is just an empty container that you can put on your web page that does not have any significant, or not significant, it doesn't have any inherent meaning. It's just a container. I'm going to give it an ID as well. I'm going to call it sensor data. So this div is a container on the web page that just acts as an empty box. It has an ID of sensor data so that I can use my JavaScript to say, look for an element on my web page that has an ID of sensor data. Put these pieces of information inside of sensor data or inside this div so that it can be seen on the web page. Yeah? So by default, if I were to look back at the web page and refresh, you wouldn't see any sign of the div. But if I were to put some data here, like this, then we'd see it here. So this is the information inside the div. But I'm going to replace this with my sensor data. So let me see. I should be able to write some JavaScript that says, instead of just console logging, I'm going to do this. So I can console log still if I want to. Yeah, man, I can. So let me see. I am going to firstly get my var sensor data container. This is a, what name there? Just a variable. Is equal to document.get element by ID. How is it? Get element by ID. Okay. So what I have on screen here now, firstly, let me make this a little bit bigger so you can see it. This? Okay, don't need this. All right, it's this. It says var sensor data container, I spelled that wrong, is equal to all of this. Var would be like your int or your bool or your float. It's your data type. JavaScript don't really pre-data types like that, just like Python, but you still need to at least let JavaScript know that this is a brand new variable that you're creating. So you put var in front of it, just mean variable. So this variable is going to be equal to document.get element by ID sensor data. This document is your whole web page. And from the whole web page, we're looking for an element that has an ID of sensor data, which is the div that I created in my HTML. So I'm telling it to look for this element here that has an ID of sensor data and store that element inside this variable. So it stores a reference to that variable, that element, that div in this variable. So with that now, I should be able to programmatically read from that element or add to that element. Yeah? So I'm going to do something like this. So once I have that, let me see, container. What's a container spell? Is the web page, the whole web page. And from that web page, I'm trying to find an element that has an ID of sensor data. And I should be able to, let me see, what can I do? I can use a for loop and just add stuff to it. So for loop in JavaScript is the same as a for loop in C. So I can say for var I equals 0, I less than, and I want to get the size of the data. So I'd use data.len. That's all? Length. I++. Let me make sure. JS array length. Yeah, it's just length. Okay, yeah, it's just length. So I should now be able to say this variable dot, what do I say, append child? Let me say append and just append data, square bracket, I. Will this work? Oh, it did, except it didn't actually parse the data. So I was able to get the objects onto the web page, but they're not parsed in human readable language. They're just objects, so I need to parse them first. So let me parse them first. What data do I want to get from them? Let me see. So these have timestamps, sensor ID, temperature. So let's get the temperature ID first. So what I want to do is I want to get the what's it called? Sensor ID. Let's get sensor ID. Sensor. That's all? Underscore. Oh, so I got the sensor IDs. But let's see if we can put them in a row. Can I put them in a row? Append plus BR. New. Okay, this is a lot more complicated than I want it to be. Well, let's say, all right, let's just create them first. I want, what do I want? A div. No, that's not what I want to do. Let me see. Oh, document create elements. Okay, cool. That worked. Okay, let me walk through this. So in my for loop, I did three things. First thing I did is I created a div. And a div, again, is just a generic element. So I created that div, and then I added some information to that div. I used elements, so I called them my variable that used to create and store that div, element. Then I say element.innerHTML. What I'm saying is the information or the HTML inside that element should be equal to this data. This data is the same data that I got from the response body. So I'm getting the ith element, and from it I'm getting the sensor ID. Let me just show you what that looks like. Going back to this here. So these are my sensor data. Oops. That's the data I got from the API. It's an array of JSONs. They have a timestamp, a sensor ID, temperature, humidity, and pressure. So I'm just going into my JavaScript, and I'm looping through that data, and I'm getting the sensor ID for each one, and storing it inside of the element that I created here, which is a div. And then I take that element, and I add it to my container. And I do that over and over. And since I'm doing it 3 times, or as many times as there are temperature readings inside my JSON, it just appends them to the screen. You wouldn't just do this for the ID, because I just extracted the ID. You'd extract all the data, or all the relevant data. Yeah? So I could probably do something like this. Can I add a hyphen here? Oops. Plus a hyphen, and then say plus, and then do a right. And this would be the temperature. Let me copy this. Okay, under that? Copy that. Put that there. And then we'll go back to our web page. See? So ID is this temperature. So that would be one way of doing it. Ideally though, you probably want to put it all in a table. And that can be done. It's a little bit more involved than doing it this way, but it can be done. You could do it manually. You could use a library. There's a library called data tables that you can use. JS data tables. And you know what? I would suggest using data tables instead of doing it manually. Because doing it manually is insane. Let's see if we can get it working. So, okay, how we get data tables working? Browser. You need these two things. So I'm going to copy this. Yeah. I don't know how to do this. Oh, here it is. And then in my JavaScript, this says I just need to do this. Oops, go here. Do I need to create a table first? Didn't work. Data table is not defined. Do I put this down here? Oh, I need jQuery. Data table is not defined. Data table. I could just give me jQuery. Data table is not. Do I need anything else? So I have that. Let's ask Claude. Can I use this? really? Yeah. All right, I'm almost definitely going to have to figure out why it's not working and come back. But I haven't done this in such a long time that I'm probably not going to be able to do it now. Read code. Just the HTML code. No data passive data table. So no data. You created a data table but never fed it any. You need to pass the columns and the data. Data table needs that and that. Incomplete. All right, fix it. Okay, so what did it add? It added the data tables, added jQuery. Isn't this already? Oh, yeah, that's here. So does it work now? Oh, it does work. No, it doesn't. It doesn't feed in the data. Blocked by cores. Didn't already. Oh. Oh, it worked. Cool. So here's my table. What did it do though? Okay, well, this one. So I have to specify that the data comes in this variable. I have to specify my columns because it can't just know it explicitly or implicitly. And then I think the imports are fine. I don't know. Either way, I'll post this code on VLE so that you have access to it. So you know how to get your data from your API and put in a table on your web page. Oh yeah, this is an example. Let's see, temp-01. Yeah, that's cool. Yeah, and I think with that, I should be able to stop here for today. The recording will be available so you can go watch it over when you're ready. And I know you came late and Matthew's gone, but you have any questions? That's fine. All right. All right, cool. You have questions about this? Okay. Hold on 1 second. Okay.
Oh.